Hi, everyone. Hey, I'm Daniel. Um, that's what I look like on the internet. That's what I look like in real life. Kind of the same. Before we start, who here wanted to go and see Venkat's talk and is stuck here with me instead?
This was my first choice, actually.
Woo, first choice.
Venkat is so.
As we're speaking, he has 566 hearts. And I wanted to go see his talk, but I'm stuck here with you, so we're gonna have fun. It's gonna be nice. Before we start, my 3-year-old is very curious at what I'm doing today, so can you please make a funny face for him? And 1, and a 2, and a 3. Amazing. He's gonna love you guys. Cool. So I work for VMware in the Tanzu Spring group. So it's between the Tanzu brand at VMware that does packaged products and the Spring group that does the open source that you all know and love. I also teach at a university in Paris in my spare time, Python, web, and stuff like that. You can find me on the internet, and you can find me here after the talk, during the break, and we have Tanzu VMware has a booth downstairs right in front of the cloakroom, and I'll be there during lunch. So if you want to come and ask questions, I'll be available for you. So before we start on Spring Security, who here uses Spring and Spring Boot? Raise your hands. Cool. Yes, that's a good start. And who uses Spring Security? Cool. And who thinks Spring Security is really easy to use and easy to understand? One hand, one hand. Cool. You can come and co-present with me. So that's why I'm here. I am going to share what I've learned about Spring Security by contributing to it. Spring Security has it wants to be used in a certain way. And when you go past the getting started guide that you find on the internet and you want to tweak it to your use case, usually it's very complicated. And so you go to Stack Overflow and you copy and paste some stuff and it doesn't work and it's very frustrating. That was my experience before I dug in and tried to understand how it actually works. And it's not that difficult. It's complex as it has many things intertwined. But once you have the basic concepts, it's really easy to extend and make it do what you actually want. So the contents of what we're going to be talking about today. First, we're going to do a demo. And the goal of the demo is not to show you the cool features of Spring Security and make you remember all the cool things that you do. It's more, we're going to do a baseline, and then from that demo, we are going to be talking about theoretical concepts or the architecture of Spring Security, the patterns, and we're going to extend on that demo. So bear with me with that. And then we're going to talk about the main concepts of Spring Security. So a few caveats before we start. The goal is not for me to infuse all the knowledge of Spring Security to you in 3 short hours. The goal is to give you pointers so you can start looking in the right places when you want to extend your app and you want to secure in different ways with Spring Security. So make you somewhat autonomous or give you the first steps on a journey to autonomy with this library, rather than going to Stack Overflow and being very frustrated by this 2013 answer. The focus of today is going to be on authentication, so the identity of the users or the entity that log into your app. Spring Security also covers authorization, but we only have 3 hours and I want to go a bit deep, so we're going to focus on authentication. We're going to be doing this for the Servlet architecture, so for Spring MVC apps, not Webflux. Webflux is slightly different, but slightly similar, and so if you have the concepts of this architecture, the Servlet architecture, you should be able to find your way through with Webflux apps. And finally, Spring Security 6 is coming out, I think in November. We're working on this. So It will be Spring Security 5.7, so not the latest, that's the bleeding edge. I'm not going to go in a milestone for a demo. But the patterns I use are forward compatible, so you should be able to reuse the same patterns in a Spring Security 6 application. So everyone here uses Spring almost, I think. So that's good, because if you don't use Spring, this is going to hurt a little bit. So let's get started with this. Let's do a little bit of a demo. If you want to follow along, here's some code. I think it's better to watch me do it instead. But you'll have the links to this repository at the end of the talk. Cool. So if we start a Spring project, we usually go to start.spring.io, right? We're going to do a Gradle project. We're going to use Java, not to be too fancy. And this project is going to be Devox Belgium, right? And we use Java 17 because it's really cool. So Spring Security is for securing web apps and web endpoints. So we use Spring Web. I'm not going to use security right now. We're going to be adding it as we go and see how that changes things. I'm not adding the dev tools either, because it does magic for you that I don't want in the demo. So we just have a Spring Web application. All right, here we go. This can go away. All right, and then make a new thing. We go to temp, we move the thing we've downloaded that I called Devox BE here, unzip it. Is the font size all right? Maybe that's a bit small. All right, unzip this, then we go here, and we open this with our favorite editor. Yes, I trust, it comes from start.spring.io. And all right, so while this is indexing, this is a basic Spring project. Let's wait for the internet to be downloaded. Perfect. So, it's a web project, so we need some web endpoints to showcase this. So we're going to create, let's call it a web controller. That's an awful name, but you get my drift. This is going to be a REST controller, and we're going to make 2 pages. A public page that everyone should be able to access. So this is going to be the default page for our app. And maybe it returns hello Devox, right? And then we're going to make a private page. And this one should be secured. This should be private. And then you put some emojis to show that your encoding is weird and doesn't work. Beautiful. Nice. Is that font size okay, or in the back, is that all right? Yeah? All right. And so we expose this over private. So obviously, if I start this application, nothing is going to be secured, right? Because we didn't do anything. Oh, invalid release. Amazing. Let's restart IntelliJ with the correct Java. All right, here we go. That's what you get for using the latest LTS. Enter presentation mode. All right, and so here, this should start. Boom, boom, boom. Work is happening. Wow. What do you want from me, IntelliJ? You want to use Java 17. There you go. Right, start again. We're gonna get there, we're gonna get there. Yes, okay, some Spring logs, things are happening. And we can go to localhost 8080, that's the default. And we have hello Devox, and of course, if we go to the private page, it's not private. So we want to secure it. And the way to do that in the Spring ecosystem is to add the Spring Security dependency. And we can do that with a Spring Boot starter. So just like this one, let me close this. We're going to add Spring Boot starter security. I think that's the right one. Cool. Then we re-import the Gradle project. and then we rerun the application once the build has finished. Right, starts again. And now, if I go to private, I have a login page. Well, the problem now is that if I go to /, I also have the login page. If I try and navigate to the root of my app, if I curl it, localhost 8080, I get a 401. It's like, it's forbidden, you cannot access here. This is one of the important patterns of Spring Security, and something you should try and replicate in your applications, is that everything is secure by default. So by default, we don't even want to expose which endpoints we have. So everything tells you it exists. If I try to go to something that doesn't exist, like foo, I don't even get a 404. I get forbidden. Everything is locked down. So to not lock it down, I guess many of you have done this, right? We're going to create a config class, and we call it security config. So in the past, you would extend web security configure adapter, this thing. As you notice, this has a strike through in it because it's deprecated, and you should not be using this anymore. This is not the pattern the Spring Security team recommends you use. It's there, you can still use it, and it will still be there in Spring Security 6.0. However, what we recommend doing instead is we say you create a config class, and you annotate it with enable web security, even though Spring Boot does that for you, and you provide a bean of type security filter chain, right? And this one takes an HTTP security, HTTP. So it's very similar to what you had with the web security configure adapter. You just have this HTTP security, and the difference is that you have to return http.build at the end, whereas you didn't have to call build with the adapter. Cool. And so what we're going to do, we're going to say authorize requests, and I'm going to use the Lambda configuration model. You can still do this Fluent API that I guess most of you are used to, and blah, blah, blah. I'm going to do it instead. This is the new, or the recommended flavor now. So authorize config, and we're going to say, so what do we have? We have a / page, and then we have the private page. So if we take the private page and we say we want it authenticated, and then we say authorize config, any request, permit all. So that means if you go to private, then you must be authenticated, and we'll redirect you to start authentication if you're not. And for the rest, just permit all. Okay, amazing. So if I do this now, I should be able to access the / page, no problem, right? And if I go to private, I have a new problem. I have an error page. And this is usually because the security filter chain here overrides a default that Spring Boot gives you. And we're missing something here. We're missing two things. We're missing the capability to log in with a form. So we can configure our filter chain and say, okay, I want also to enable form login. So if I need to log in, show me a form. And then if you go on the internet and you look how this works, you realize that you also have to provide a bean of type user detail service, which is the repository of users. Is this where your users are defined? So it can be a database, right? A JDBC user service. It could be the file. We're going to use in-memory for a demo. So we have an in-memory user details manager, new. And then in here, we're going to put a user with a username, user, and a password. Then you have to specify how you store your passwords. For a demo, I'm going to say just store them plain text, but you could have a bcrypt thing, and then we would need to have a bcrypt hash, for example. But just this for the demo. And then authorities, and we're going to say that this person has the role user, right? And then we build it, and we return this. So now when we try to navigate to our page, the default / is still public. If I try and go to private, I we have our signing form that's here, and we can use it with user password, right? So we have a page, and it tells us this should be private, but if I'm logged out, I cannot access this. Right. So I told you that Spring Security is secure by default. So by default, it would hide all the pages. And what we're doing here is not really in that vein. We're basically exposing anything and securing some specific endpoints. The idea, if you want to follow the mindset of Spring Security, is that you do the other way around. So you say the public page is public, and any page that you want to be public, say error page, the white label error page, the 5 icon are the usual ones, you make them public, and then any other request must be authenticated. So you reverse this. Because if we keep the current setup, I log out, right? Yes, I want to log out. If I go to foo, it gives me a 404. So it tells me there's no 404 endpoint, and someone can then start enumerating pages on my site and hammer the site and try and find existing pages. If we do it the other way around, then foo would be authenticated, and so someone would need to be logged in to actually see that foo doesn't exist. So restart the app again. Cool. So here, still public. Now foo, I need to be logged in. User and password. Right? And now I have a 404 because it doesn't exist. If I go to private, then I have the private page. Okay, cool. Then this, I can log in with the username and password. That's interesting. We can extend and we can say, oh, this is useful for development or this is useful for admins, but I want this to use SSO instead. So to use SSO, we could use OpenID, which is I think the most common protocol we have today. You don't have to be familiar with how it works, but with Spring Security, that's very easy. So the idea of OpenID is what you have when you have these sign in with Google buttons on your apps, right? You go to myphotobook.com and you can log in with Google. Well, this is using OpenID in the background. So to do this, we need the libraries to do that. So we are going to start auth2 client. We add a starter. Let's compile this. And then we need two things. So we need to tell our application that it should use OpenID. It should use auth2 login. So OpenID is built on top of auth2. So we tell the security filter chain, oh, by the way, I also want to be able to log in with auth2. And then since we're logging in with Google, then not everyone can just log in with Google like this, right? You can't use Google servers for authentication freely. You have to have some credentials. And these credentials, if you're familiar with OpenID, in the application YAML, we have to declare those credentials. So we're going to have a registration. We call it Google. It's going to have a client ID. For now, it's a placeholder, and a client secret, another placeholder. Cool. And so we need to obtain those client ID and client secret from Google. If you go onto the internet and you say, I want, let's make something that's not private. I want to do SSO with Spring and Google, it would tell you, then you have to do what I just did. And then you also have to obtain credentials. So we go into Google console, we create credentials. We are going to create credentials for a web application because we're not doing Android here. DevOps Belgium. And then you need to specify this redirect URI. It's a well-known thing that you would find in the guide on the internet. I'm not going to dwell over this. I don't necessarily want to explain the protocol. And it gives you a client ID and a client secret, which we can put in here. So the client ID is this one. You can take a picture, and maybe I forget to remove them after the talk. Cool. And so if we rerun this application again, cool, and we try and access the private page, and I zoom out, we have a new option. Log in with auth 2.0. It's actually OpenID under the hood. If I click Google here, hopefully, if the demo goes, well, I guess I could use this, yeah. I have to log in. Then this does SSO. So it goes to my VMware authorized provider, logs me in with that, then brings me back to Google, and then it brings me back to the site. And now I am logged in with the open the Google SSO instead of username, password. Right? So I can extend what I use to log in. Now, this is cool, right? I can be logged in, but it doesn't really tell me much about who is logged in. So to consume this authentication, this identity of the user, and display it on the page, what you would do typically is inject an authentication here in the endpoint. Cool. And then maybe we change the message here. We say, welcome to the VIP room. And we're going to have the username. And the username is going to come from the authentication, which has a get name. And as I told you, you should always put emojis, because this is how you see that your browser doesn't work on Japanese regions. Ta-da. And coffee. This is a developer conference. All right, and then we start this again. Cool. And if I go to the private page now with user and password, it says, welcome to the VIP room user. And if I try to log in with Google, right, and then go to the private page, then it tells me, welcome to the VIP room 1125-033-0963-014-888-0558. This is my subject ID in Google parlance. Not very interesting. So one of the tips and tricks of Spring Security, when you don't really know how to get the information you want, you just debug the thing, right? So we debug this application. We log in with Google. Cool. And then we get here and we see the type of the authentication. It's an auth2 authentication token. And it has authorities and has details. It has a principal. Okay. And this one has attributes, 16. That's good. And this attribute has an email in here. So I can pull the email out in case I'm logged in with Google. So continue this. We're going to make a method. Get name. Amazing. And so we're going to check the type of the principal of authentication. Get principal, import optional. Yes, that's fine. And then we're going to say we want the principals of type OIDC user. This went fast, but this is what it said. OIDC user class. Is it an OIDC user class? Then if it's the case, then we map. And we cast this to our OIDC user, and then we can say OIDC user get email. All right. And then or else, if it's not a OIDC user, so if I log in with username and password, we say authentication get name. What we had for the user, that worked fine. Authentication, lowercase a, right. So if it's a Google thing, if it's an OpenID login, I use OIDC user. Otherwise, I use the authentication. And we can start this again. And now, when we log in with Google, this is very big, okay? Right, it uses my email. Whew, cool. All right, so here's the demo, blah, 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 the code, right? So what do you think of this? Does that make sense? Is it awfully complicated? Is it too fast? Exactly. It's a bit complicated, but not very complicated. I agree with you. It's a bit complex because it touches multiple things, as in we had to change the build.gradle to import the correct dependencies. Then we had to go to the security config, right? And then change and say, oh, I want to protect this in this way. I declare it. And then we have to go to the application's YAML to inject the very secret secrets. And then we finally can use it. So it has many things that play together, but you can find this in a guide on the internet. Now, if you want to restrict the users that can log into a certain domain, then there's no guide for this, and then you have to find out by yourself. And then it gets really, you have to embrace Spring Security and see how it works to be able to do this. So, any questions on the demo? All good? Yes? Yes. So you will be able to get the code in that workshop. There's a code. It might not be exactly the same, but it's roughly the same code. You'll have pictures at the end as well. You will be able to get the slides, and so the slides will have a walkthrough of the things that you have to update. So here, your security config should look like this, etc. And the code has commits, so one commit per step of the things we do together today. All right, so let's back off a little bit and talk about the main concepts of Spring Security. I think the core of what's at the core of Spring Security is the authentication. So what's an authentication? It's what Spring Security produces and that you as a consumer use. And it's used for two things. It's used for authentication, for the identity of the user, who might be a meat bag like me, or it might be a machine that is logged into our system. And it might be with credentials, with a username and password. It might be with a complex identity protocol like SAML, or it might be with a certificate, but it's just who it is, the information we have about the user, so the email, the dates of birth, etc. And then it's also used for authorization. Is the user allowed to perform such and such action? So can I access this page? Can I post a message? Can I make an order? So as I said, we're going to focus on authentication today, but it can do both. So the authentication object in Spring Security, this one here, represents a logged-in user. So it contains the principal, which is the identity. So in here, we should have a get principal, right? And then it contains granted authorities, which is typically some sort of representation of the permissions of the user. So I have the role user, I have the role admin, I have the scope message.read, something like this. So we're going to be using the principal. And it has other stuff inside that as a consumer you don't really care about. One is authenticated. It's almost always true. So if we have made a security config that says any request must be authenticated, then it makes sense that any authentication that we get is authenticated, right? Because otherwise it's blocked. It has details inside if you want to know a little bit more about the HTTP request that came in, so the IP, for example. And then it has credentials, which is a password, or it could be a certificate, or it could be a token. It's often null, because as a consumer of this authentication, maybe you shouldn't see the password of the user. You shouldn't care about it. So Spring Security logs the user in, produces an authentication, and it's authenticated, and the password is null. And then maybe one thing that's important is that the principal here, as you may have seen, the principal is an object. So this is how Spring Security is 20-year-old, right? And this is how it supported extensibility 20 years ago. So if you are a library author and you're making a new authentication type, you can put anything in the principal. So it can be just a string, so the name of the user logged in, or it can be a rich object. This OIDC user that we've seen is a principal. And so it has, it has the email claim, it has maybe the time at which it logged in, etc. So this has interesting properties because it can put anything, and it can put very rich information. But the problem with this type of having object, this type of coding, is then through Spring Security, you will be seeing this kind of thing all the time, right? So do we support an authentication object? Well, only if it's a username password authentication token, or a CAS authentication token, or a CAS assertion authentication token, which makes it sometimes a bit hard to grok, because then you have to go in the debugger and figure out what type the principal is. And so it's not the most type-safe library in the world. It works because it has great engineering discipline inside. Like, things are really checked and really solid. And then it gets confusing, because this authentication object we have, it has a get principal, right? But it also extends principal. And the get principal is an object. So that's very, very confusing. Sometimes you will see in some demos in the controller here, sometimes you will see a principal injected here. So don't do this. It works. Don't do it. Why not to do it? Because the principal here is the Spring Security idea of the identity of the user. The principal here is not part of Spring Security. It's part of Java, right? And so this is the Java idea of what an authenticated entity is. Spring Security has more information. So that's the second pattern I think you should respect for your applications, is try and use as high level abstractions as possible, right? So try and only use Spring Security objects, and if you can't, Spring objects, because otherwise you get very confusing things. The principal.get principal, if you've ever written principal here, principal, and you import this, fine. Then it's a principal here, but it's actually an authentication, so you cast it. Cast to authentication principal, right? And then you have principal.get principal. What does that mean? You should probably not be doing this. And it's not even working. It's missing a parenthesis, right? So this is very, very confusing. Don't do this. Stay in the Spring Security world. Use the Spring Security abstractions. They're usually good enough for what you want to do. And authentication, very good. Cool. So for your apps, you use authentications. And this authentication is an interface, right? It doesn't have much inside. It has, the name, the principal, the credentials potentially, and the authorities, right? So for your applications, you use authentication. And then if you make some specific behavior that doesn't imply a user that has a username and a password, then you don't use username password authentication token. This is the common thing you do in the beginning, because when you do form login, you have a username password authentication token, and so you try and reproduce it. But if your thing is not a user and doesn't have a password, it doesn't make sense to make this. It makes more sense to create your own authentication class or implementation. And you can see, if you look at the subclasses, you even have testing authentication tokens. You have special implementations of this for testing, right? So it's very easy to extend, only a few methods, and we'll see how we do this. Cool. So authentication object. What does Spring Security do with this? So it produces that, and how is it possible that I get it through this injection in the web controller? Well, it uses something called the security context. The security context is basically the holder that has the authentication inside. This is only true in the servlet world. In reactive, it's different. It's a global static object that you can access anywhere, and that is alive in the thread. So anything in the thread that is processing the request has access to the security context. So that means in here, instead of injecting the authentication, we could do security context holder, get context, get authentication, and we obtain the authentication, right? And this works in the exact same way as injecting it. So why is this interesting? Why is it implemented this way? Just still gonna test it, make sure it works, right? So we can log in as a user. So why is this interesting? So it's interesting for you as a user if you happen to have your controller call, I don't know, a foo service, right? And then this foo service is a component. It has a bar method that takes a baz, right? And then in here, it calls the cuck service, which does blah, and then passes baz, and so on. If this blah method needs to have an authentication as well, that means you don't have to pass it down into 5 method calls, right? So you could just get it here where you need it, right? You say security context, holder get context get authentication, and you obtain the authentication, right? So you don't have to see if you have five services deep nested, you can obtain the authentication like this. It also allows Spring Security to do stuff like pre-authorize, and you say, oh, it must have is authenticated and has role admin, right? And so the way it does this pre-authorization is by looking up the security context, extracting the authentication, and verifying this. This is not a recommended pattern to just do this, right? This is authenticated, has role admin, can be expressed at the endpoint level. And we recommend you do this. You protect the endpoints, and the methods themselves don't necessarily need to be protected. But if you have very sensitive methods, you're 15 people working on the same code base, and you want to express, yes, this must be only for admins, you can do some sort of defense in depth. So the endpoint is protected, and if someone forgets to protect the endpoint for some reason, the method is also protected. And this is happening thanks to the security context. Now, if you remember your computer science classes or what your mentors told you, you should not be using global static objects. Why does this work here? This works because this security context holder is a thread local variable. That means it's only available in the thread that's processing the request. If I spawn more threads, they're going to talk to the database or do more calls. They do not have access to the security context. So if we do a new thread here, and so it's a runnable inside, and this thing does security context holder get context, get authentication, and we're going to replace this one, and we call this one in thread. In thread. A little plus to show it, right? And then we do the one out of thread, outside. This one is the authentication we obtained from outside. And this is the thread, t, and we do t.start and t.join. So we wait for the thread to complete before we do the rest. Fine, exception. So we run this again, and we log in, user password. And then in here, outside the thread, I have a username password authentication token, right? It has a user, it has some stuff. And in the thread, it's null, right? And this security context holder is then cleaned after the request is processed, because if you use Tomcat, so if you use Spring Boot with Spring MVC, it's likely that you have a Tomcat inside. It has 100 threads. It computes the number of threads it wants, depending on the machine, and then each request that comes in runs on a thread. When it's done, some other request is going to use it, so the security context must be clean so that the next request doesn't steal your authentication. Cool. All right, so this is the mechanics of where we get it. But usually when you use it, you just inject the authentication. Right, so security context holder contains a security context, which contains an authentication, and it has a principal, it has authorities. Most likely, we're going to care about the principal in this demo, or in this session here today. Do we have any questions so far? Okay, so before we get into coding again, we need a little bit more than just authentications, because this is how we consume them, right? But how do we produce them? And usually we produce them through the second building block, the filter. So this is the servlet architecture. So servlet containers such as Tomcat, JBoss, WebLogic, whatever, it works like this. You have a client that makes a request, and the request to an endpoint is going to hit a specific servlet. The servlet contains the business logic, so if my endpoint is /orders, the servlet is going to produce the list of orders for the specific user. Between the servlet that produces the response and the client, there's first a list of filters. The filters are used to do common things between requests. So they're used to do side effects. So if I want to log stuff, right? I don't want to be going into every endpoint that I make and write some logs. So I can have a filter that's reused between all the servlets and that logs the request. They can do pre-processing of the request. And so, for example, they can do authentication. So they can read my session cookie, verify that the session cookie matches something in the database, and then load the user information in the thread local thing that we use. They can do pre-processing for security reasons. So for example, if I'm trying to access an endpoint that's protected and I'm not logged in, it can cut. And so maybe filter 1 here will cut the processing. And this has nothing to do with Spring. This is Servlet. Now Spring has its own way of doing filters. So it has this delegating filter proxy that wraps a bean inside. And this is mostly for lifecycle reasons, because the bean lifecycle is not necessarily the same as the containers. So what you should remember here is that Spring has its own flavor of filters. And so it's filters all the way down because Spring Security has a delegating filter proxy that wraps a security filter chain that itself has filters inside. And so when you operate in Spring Security, you actually operate at this level. So it has a concept of a security filter chain, which is exactly like the normal filter chain. But it's the single entry point for Spring Security. So when you're trying to secure your app, you will never, ever write stuff like this, the filters on the main path, right, on the container. You will be adding stuff into the security filter chain. So it's important to know that there might be multiple filter chains that have different logic depending on the path you're trying to hit. For our demo, we're making one, and that's enough. But you should know it exists, the concept of having multiple filter chains. So what's interesting about this is that you can see the filters that are actually wired in your application by going to the default security filter chain. If you don't remember this, you should remember this is a security filter chain, right? Then you look at the implementations, and there's one. It's the default security filter chain. And it's calling this constructor here. And if we run the application in debug mode, we should hit that breakpoint. And then we see the filters. And we can see all the filters that Spring Security is injecting into our application. And so if you're trying to understand what's there, what's not there, why is it missing, then you can look at the specific instance of filters here. Okay. So what do Spring Security filters look like? What's the general layout? Well, it's this. It has a doFilter method, takes a request, a response, and the filter chain object. So it's in 3 phases. One, before the request is processed, anything that is an authentication process, an authorization decision, the decision to whether this filter should do anything to the request or not. So it happens before. So when you log in, it usually happens in the section 1. Then once it's done, it says, yes, okay, I've done what I had to do. Then I'm yielding back to the filter chain to continue processing. And then once the request has been fully processed, so once it has gone all the way down to the servlet and it's coming back up the filter chain, we can do some cleanup. And usually you don't want to do this as a user. It's some very specific filters that do this. So for example, the filter that cleans the security context does that. It says, yes, the request has been processed. The user has used the authentication for whatever they need. I'm going to empty that thread local thing so that subsequent request cannot steal the identity of the user. Okay, so 1, 2, 3, very simple and straightforward. Now, as you notice here, we call chain the doFilter, because this filter chain here is not doing a loop over a list of filters. It's not a for loop. It's actually a chain of responsibility pattern. So we have a filter chain that has a list of filters inside. It has a current position for the request. It starts at 0. So we find the first filter by looking up the filter at position 0. And then on that one, we call doFilter with the request, the response, and the filter chain itself. Then the filter does the processing like this, and then it calls back to the parent, to the filter chain that calls it, and says, do filter again. This one increments the position, gets the next filter, calls the next filter, right? So it's not a for loop, it just goes down and then all the way back up. So the stack trace, if you represent it as a call stack, it looks like this. The filter chain A is going to call the filter 1, and once the filter 1 is done processing, it's going to call chain.doFilter, is going to call the filter chain again, the same filter chain. And then filter chain A is then going to look up the next filter and call the filter 2, and so on and so forth. And so that's why we have this step 3 here. It happens after the other filters in the stack, down the stack, have done their thing. When we go back up, we do the cleanup. And so this is an important thing that you need to understand if you're debugging Spring Security, because sometimes you will see stack traces like this that may look very confusing. It has do filter everywhere. So first, all the filters have do filter. So that's why we have different filters here. For example, the filter security interceptor, the exception translation filter, session management filter, and so on, which we can find here, right? Filter security interceptor, exception translation, session management, and so on. And then between all these filters, we have the same do filter at line 336 in the filter chain proxy virtual filter chain. So this is the dark blue calls here when we're calling back to the parent. And so if you want to understand which filter is being processed, let's continue this. It's in the filter chain proxy. All right, and then in here, around 300 and something, there's a do filter. And you can see here, there's the current position and the next filter. So if we make a request, anything, foo, right? Fine, go away, pop, cool. We can see first it's going to call the disable encode URL filter. Then we step up and it's going to call the current position 2, so the web async manager integration filter, the security context persistent filter, and so on and so forth. And this is how you debug what's happening bit by bit. We'll see other ways of debugging this in the rest of the talk. Okay, cool. Enough with the theory for now. Let's take a deep breath. Relax. Lots of word thrown at you. Usually when I teach, it's by that point that half my class is asleep. I congratulate you for not falling asleep. Do you have questions around the filters and authentication so far?
What's the reason for not having a loop and instead having this?
So the question is, what's the reason for not having a loop and instead having this chain of responsibility pattern? This allows you to do this 1, 2, 3. If you have a loop, you do 1, 2, right? Or like 1, 2, there's no 2, right? You just do the processing and then you move on to the next one. But if you do the chain of responsibility, you nest things and you say the first filter, so let's say you only have these things with filter 1 and 2. So we go from A to 1, 1 calls do filter. We go back to A, goes into 2, 2 calls do filter, then the filter chain A says, ooh, I'm done. And so we move on to the next thing here. We do the cleanup after the full processing has happened. Cool. Another question in the back. Is the security context extendable? I think so. I think it's not final. I don't think it's a good idea to extend it, or I cannot think of use cases for doing this. It's probably possible. I've not seen it in the wild. Usually you would extend more of the authentication class. So how to log in, and then once you're logged in, what you look like, but not the machinery that contains the crown jewels. We had someone in the...
Even your security filter in step 2, there is an exception. Is it called in a finding block?
Yes, it's a call in this filter chain mechanism. It has mechanisms for that. What's really interesting as well is that since you're doing this nested chain of responsibility, you can have a try-catch around this do filter. So if any subsequent filter throw an exception, then you can catch it and decide what to do with it. And if I am not mistaken, this is what the exception translation filter does. Right? It tries to do subsequent filters, and if we have an exception that happens, then it will decide things based on the type of the exception that happened. So for Spring Security exceptions, right, it has authentication exception, and then maybe authentication exception is going to say, well, you should be logged in, so I'm going to send you to the login page instead. If it's an access denied because you're not allowed to be here, I'm going to give you a 4 or 3, you're not allowed to be here. Yes?
If you have multiple security filter chains, who's responsible for
Right.
which one to use?
Exactly. So there's a question around what happens if we have multiple security filter chains. So filter chains, let's go into security config here. They're declared as beans, and you can give them an order. Right, and then you can say, oh, this one is 25, why not? And then I create a new one, it's 42. And it's going to try them in order, in the order of the beans that are declared. And now you can say this filter chain here is only for API, right? So first it tries, this one is my first, and then it says, ooh, the request that comes in is /API. This filter chain is able to handle it. Then this filter chain takes it, and the subsequent filter chains, the other filter chains do nothing. Now, if I go to /login, first it tries this filter chain 25, and then it says, ooh, this doesn't match /API, so I'm not going to do anything with the logic that's in here. Instead, I'm going to try the next, and maybe, if we duplicate this one, cool, and then we call it security filter chain do, amazing. And then this one is 99, it comes after, and maybe it only protects foo, so it does nothing. Or maybe it's for everything, and then in that case, it's the last one, it's the catch-all. Now, if you mess up your order and you say this one is the number 1, since it has no filter and it accepts any request, this filter chain is going to be the only one that's used throughout the app. Yes? Yes, so the question is, can you specify a user detail service for each chain? Yes, you can. You can specify any logic you want for any filter chain. So we had a chat with my developer advocate colleague, Dan Vega. He's been doing videos about Spring Security lately and JWT authentication. And so we simulated a thing where a filter chain had the /API protection, and you could only log in with a JWT token. So you cannot log in with username and password. And then we make a separate filter chain under /login, where there's the user, the global, the username password authentication, right? And so they can be completely separate. If you go to that login filter chain and you send it a JWT token, it just doesn't work because it doesn't know what to do with it. It's not configured for that. And we'll get back to user detail service and like this in the rest of the talk. Cool. Any more questions? Very good. So we were at kitties. Now we get a little bit of energy back, and we can start implementing. So it's been a little bit less than an hour. Is everyone fine if we push a little bit more, do some coding? Yeah? Okay. So I have to delete this, otherwise it's going to break everything. We mentioned filters, and we said, well, the filters are important because this is where all the secret sauce happens. So let's make our own. we have a rep, and it has 2 pages, and it has form login, has OAuth2 login. Very nice. Now I have a new use case, and I want a robot account, a service account, to connect to it with, say, a special header. And so how do I do this? Because form login in here, if I had a robot to try and log in with form login, then the robot has to download the login page, extract the CSRF token from it, craft some requests, get a cookie, use that cookie to do stuff on my app. That's very inconvenient. What I would like to do instead is being able to call localhost 8080, the private page, and then with a special header that says X robot password, and I call it with beep boop, like this. Right? So if I do this, it just doesn't work. It tries and redirect me to the login page because I'm not logged in. And we want this instead to give us a response if I give the correct robot password. So if you've been paying attention, here we should be implementing a filter, exactly, a security filter. Robot filter. So here we have to implement something. If we go for filter, this one, the Servlet one, that works. We can do it. But first, I told you not to do this. So you haven't been paying attention. That's not good. And second, you have to implement stuff. And the methods you have to implement are init, destroy, and do filter. And so suddenly it's a bit complicated. What's in the init? What should I do with the init? What should I do with destroy? So instead, what you want to do is go in the Spring world instead. And the classic filter in the Spring world is the generic filter bean. And this goes into the Spring framework, so we're in safer territory. Now, this is anything that wants to be a filter in the Spring world. We have more specialized filters for this. To find out, one thing you can do, is here, go to the diagrams, show the diagram. Here's the class hierarchy of this. It implements filter, it implements a bunch of things. We can look at the implementers of this. Then the diagram is completely unreadable, which is to be expected. Is it working? Yes. I can't seem to be clicking. I think I have killed my machine. There we go. Let's try again. Fill diagram, show diagram. Yeah, okay. I can't choose the layout. No. Layout, is it graph radial? There we go, beautiful. Boop. Right, so our generic filter bean is here, and there's a bunch of stuff, filter chain proxy that we've mentioned. But you can notice there is another annoying pop-up and another interesting filter here that most filters seems to derive from, and it's called once per request filter. And so this looks interesting because most of the filters we want to do, we just want them to happen once per request, even if you mess up and you register the same filter a bunch of times. So I would recommend go through this one instead. Okay, boop. So once per request filter. And when you implement this, there's only one method, and it's called doFilterInternal, not doFilter, but you get the idea, right? So same as a normal filter, it takes a request, it takes a response, and a filter chain. What we're going to start with is just say robot hello from the robot filter, right? And that's it, right? So if we run this, and make a request. I mean, I can keep the beep boop, that's fine. Then nothing, oh yes, let's do a normal request here, so we could, right. Then nothing happens. Because I have created a class, but I'm not using it anywhere. So we have to instruct Spring Security to use this thing. So in the security config here, close this, close that. We can say add filter. If we just add the filter like this, it's going to blow up and tell us, but where do you want to add it in the filter chain? And it's always a good question. So one way you can decide it is by, remember this default security filter chain that has a constructor that we put a breakpoint in. You can check in there and decide where you want to put it. You can Spring Security docs. You can go in the Spring Security website in the, let's make it white, cool. You can go in the architecture, and it has security filters, and then you can see the list of all the filters that, that Spring Security can give you. Basically, you want to hook onto something that you know, and then this username password is usually in your filter chain if you're doing username password. What's really important is that happens before this filter security interceptor, which is basically the thing that secures your endpoint. But if you're in doubt, username, password, authentication, filter.class is a good guess. I add filter, and then you have to say before, sorry, before. The real thing that you really want is filter security interceptor. You want to be sure that happens before this. But this is fine. It happens before trying to log in. Cool. So run the app again. Line 20, you need to remove the ant matcher to API. Thank you very much. So run again. And then this, right? This is happening. And we get hello from the robot filter, which is good, except if I try and go to the normal page, that's not working anymore. So if you've been paying attention, what's the problem here? Do filter, it's missing do filter, exactly, right? This is it's not a for loop. So to know to do the next steps in the request processing, we have to call filter chain.doFilter, request response. And so in here, if we go again, then everything's normal. Cool. And we have our log, which is not what we want to do, but it's in the filter chain and it hasn't broken anything. Very good. So we need to do our approach, right? One authentication decision, and then to do the rest, trademark. So how do we do this? Well, we get the request, we get the header, the one that's called xrobot password. We say this is the password, and then we compare it to beep boop. So if it equals the password, then this is OK, thumbs up. Else, no. So what do we do here? Well, basically, we're going to be creating an authentication, and we're going to put it in the security context. So how do we do this? We do security context holder, create empty context. This is going to be our new context once the authentication has happened. And this is one of the other important patterns in Spring Security. It's immutability. You don't take the existing context to go tweak the authentication. You create a new one, and then you load it. So in the new context, we're going to set an authentication. We'll see what we do. And then security context holder, set context, the new context. And then we have to do this filter chain do filter. Boop, I'm going to take it, put it here. And then just to be sure, after this, we do return, which we don't need to do. But if I happen to add some code here, the return guarantees that I'm not going to do it by accident on my way back once all the request has been processed. And now we have to decide what authentication we put here. So we could do a username password authentication token, authenticated, but then principal credentials authorities, it's not really a username and password. It's a special robot thing. So instead of doing that, we create our own implementation, a robot authentication. Create this. Cool. And then we have to implement the methods. So there's a bunch of methods that we have to implement, and we'll go through them one by one. So one is the name. That's easy, and we need it to display this is Mrs. Robot. right? Okay, then we also need to implement, we said the principal. And in that case, it's just going to be a string. We are going to get the name. So maybe, you know, it could be a richer object. Maybe we want the birth date of Mrs. Robot, but maybe just displaying the name is fine. Then we need to implement some of those. So is authenticated is easy. In that case, it's always true, right? We said when we have an authentication, it's authenticated. Cool. So since it's always authenticated, then the set authenticated, we're going to say don't do that. This is, again, the same pattern, immutability. We don't change those objects. We create new ones instead. This is for compatibility reasons and legacy reasons that we have this set authenticated. Then we have details. Well, the details, they can be null, and I can hide this. Okay. Then we have, what else do we need? The credentials. Credentials said they're, most of the time they're null, so leave them null. And maybe the last thing that's interesting is the authorities. And so authorities, utils, maybe we say this one has a special role robot, which we're not going to use here, but let's make one. Why not? Cool. And so our filter here, in the case we're OK, it creates a new robot authentication and puts it in the filter, in the security context folder and continues. If it's not OK, we should not process the request further, right? We should say, no, the password is wrong, go away. So to do this, we take the response and we write to the response. So first we set the status, and HTTP status forbidden, right? Like, no, 403, wrong password, go away. And then we write to the response. Writer, print, you are not Mrs. Not Mrs. Robot. Fine, forbidden, cool. And since I put emojis, because I'm a smart ass, we have to set the encoding to UTF-8, otherwise it doesn't work. And we also have to set a header because the browsers don't like it if we don't. Content type to be text plain char set UTF-8, right? So we were basically writing to the response like this, and then nothing happens after this, return again. So to try and make this more like 1-2, here the do filter is in the middle. What we can do is we can invert this and beep boop. If it's not equals, go away, and then otherwise we're okay. So we log you in and we do the next thing in the filter. So run this. And now, so if I try and go to private, it says you are not Mrs. Robot with 403, but if we do private with the password, beep boop, welcome to the VIP room, Mrs. Robot. And if I try a wrong password, beep beep, forbidden, right? That's why you have emojis, because it's very easy to read. Cool. Is there a question with this so far? Yes?
Do you really have to write the response yourself? Or can you not just throw an exception?
You could throw an exception. This is more to demo. So instead of writing the response, you could throw an exception, and Spring Security would do something with it, and we'll see that. Here you write the response. If you throw an exception, you'll get just a message that tells you there was a 500 or a 403. It doesn't give you necessarily the details, and you have to configure some things. So here I want to showcase you can write the response. It's what Spring Security does. You don't have to, and usually you don't. There's a problem with this application. Yes, sorry.
Here you extract the robot password and check it.
Yes.
Is that a normal pattern? Because I think shouldn't you separate?
So I'm doing everything in this, so we can see all the mechanics of the filter in place. We can discuss at the break. There are higher level constructs than this once per request filter. So the thing that you would be using if you're doing a lot of Spring Security is the using the authentication filter, this thing here. And it has a bunch of constructs that tells you how do you make an authentication from a request, the converter. How do you authenticate? How do you handle success? How do you handle blah? And so basically you construct one of these objects and you say, these are the different steps, and it's already wired in for you, the try catch and the stuff around this. Well, we can discuss it at the break. Yeah. You should not break the chain? That is not exactly true. So if we look at one of the filters that we're going to show later, the CSRF filter here, it definitely, if the tokens are not equal, it tells you like, no. And I'm not going to do the rest because it's securing things, right? If you're sending data and it's going to get written to a database, it must stop. So some filters do break the chain, and it's a normal behavior. If you're doing a filter that is just doing, just logging, side effects, stuff like that, you never want to break the chain because otherwise you get this blank page that we had. Speaking of blank page, if I go here now, I have a problem. My public page is you are not Mrs. Robot. This is because in every request, we extract the X-robot password, which in this case is null, and we compare it to beep boop. But the browser is not sending this, and it shouldn't send the password. It's a special case. So the filter should be a bit more complicated than this. First, we should check whether there's a step 0 implied here. Should we execute the filter? Right? Because when we do, for example, when we do OAuth to login, and we're sending a username password form request, we're not going to do anything auth to. So the auth to login says, not my problem, just do the rest. So here we're going to say request get header names. We're going to check that there is an X-robot password. Right, collections, make this a list. And does it contain, yes, contains X-robot password, right? And we can put this in an if. So if it doesn't contain, we're going to do something. Let's make a field out of this X-robot password, initialize in the field, everything, and we call it header name, right, in both. So if there is no X-robot password, we just do filter chain, do filter request, response, and then return. That it says it's not my problem. And it's a very common pattern that you check, ooh, is this a special endpoint that I should be listening for a username and a password? No, then I'm not doing anything. Okay, run this again. Now our public page is still public, the private page is still private, and I can still log in as a username and a password. And in here, the beep beep fails because it's the wrong password, and if I try and log in with beep boop, then in that case, it works. And we have a pretty standard filter implementation. This is what Spring Security does, yes?
Is it not safer that in your filter you check for the existence of the password, and if it is, you set the security context, and if it's not, you just do filter?
So the question here, is it not safer to check that the password exists and matches? And if it's the case, I set the security context, otherwise I do filter. Well, I want to send a signal that the password is wrong. So I check the value of the password, and if the password is wrong, I want to do something special and say, no, this is really, you're trying to use the auth mechanism, but it's going wrong, so that when my users come in and try and hit this, they don't have a thing that tells you, ooh, you should go to login. It tells them, ooh, you're not the robot. That's not working. Wow, you've held for 74 minutes. Congratulations. Congratulations, everyone. I think, so what's the time? 10:45. I think we can take a, let's say, 20-minute break, 11:05. If you have questions, please come along. and grab some stickers if you want. And see you in 20 minutes. Cool. Welcome back. You came back. I'm impressed. I'm happy. I hope you got some coffee to go through the second half of the talk. All right, so before we go into more coding, a little recap of what we did before the break. So we created a filter that makes an authentication decision. It takes a request and a response in. It reads from the request. It can write to the response. It creates an authentication object, and it puts it in the security context. We used a meaningful class, not a username password authentication token. And then we have to register that filter with the filter chain for this to work. So this is basically what you've seen is what is implemented by Spring Security, but for a production-ready example. So don't do that, right? Don't do boot passwords in prod. So let's take a look at a real filter and how it's implemented, and one that has some logic in it. So the CSRF filter, cross-site request forgery protection filter. Who knows what cross-site request forgery is? 50–60% of the room. So quick explanation of what this is. This is a thing, an attack, an exploit that is now mostly mitigated by the protection that modern browsers put on cookies. But still, it's been on for a long time. So the idea is I'm a normal user. Step one, I open my computer, I go to the bank.example.com website, and then I log into my banking website. And so when I log in, I get a cookie that points to a session ID that says, this is Daniel, he logged in, he's allowed to use the website for 2 hours or something, and I can do some stuff. So my browser holds that cookie. If I keep my browser open, and later on in my browsing session, I visit a malicious website, an evil web application that pretends to be, I don't know, something else, something about cute, cats and dogs. And then on the page, there is a big button that says, click me for more cats. And I am enticed to click it. The problem is that the button is not just a button like this. It's a form, an HTML form, and it has a lot of fields inside, and they're all marked hidden. But and with hard-coded values in it. And when I click click me on the website, it posts not to the evil website, but the form action points to the bank application. So now I'm making a post request with my cookie to the banking application with values I have not seen. So for example, transfer money, 500 euros to Daria, whoever. And so maybe, I'm transferring, I'm making a payment order that I don't even know exists. I have used this, so now this is mitigated with cookies, but I have used this on the same site, the type of attack. So when I was a student, we had some sort of internal social network, because it was more of an open profile page. And so you would put your name, the classes you attended, a picture maybe, what you like eating, whatever. And then it had a blank field at the end, a big blank field, where you could put anything you wanted, including unescaped HTML. So what I did is I created animations, whatever, and then a form and a button that says click me. And the form did a post to the same site saying, my name is I love Daniel. My favorite food is eating with Daniel. And then the blank field on the person that clicked me, I would inject my own form so that it spread like a virus. Everyone had my click me button in the end. And so the way to mitigate against those type of attacks is with a special CSRF, cross-site request forgery token. When a legit user makes a request to their banking website, they have a cookie, they have a session, the server generates a token. and it says that maybe the value is YYY. And it says for session Daniel, the token is YYY. When I am visiting that site and I go on a form, it sends me the form, but it also puts a hidden field that's called CSRF, and it puts the value YYY in it. So when I click post, it sends the value I typed in the form, and it also sends the CSRF token. So the banking website checks the token and says, you sent me YYY, what's in your session? It's YYY, it matches. Cool, I'm processing the request. Now, if an evil website makes a form that posts to the bank, they don't know my token, because only the bank can generate forms with a token that's stored on their servers. So either they don't put a token or they put XXX, and when I click me, then the banking website receives the malicious payload and receives CSRF token XXX. It checks what the CSRF token in my session is and says it doesn't match. This token was not generated by a legit website. So this is an attack, and we're saying no to this. And so the way this is implemented is, Spring Security is with the CSRF filter. CSRF filter. So by the way, I'm going to walk through the filter, but if you want to learn a little bit more about this, Spring Security docs are actually a great place to go. They're my third favorite place on the internet, after production and start the Spring.io, of course. So in here, if you want to get a condensed version of this talk, you go to Servlet application architecture. Surprise, all the images that I stole. And then if you want to check features here, there's protection against exploits. And so there's common exploits. So one of them is CSRF, and it tells you what is a CSRF attack and how you do it, and then how we mitigate against that. And then it has protection against other things, and it explains how, like, which special headers we inject and so on and so forth. Right, so CSRF filter, what it does in here, if we look at this, remember it has a do filter internal method. So first it checks, it tries to load the CSRF token from your session, basically. If it's null, it means you had no token before when you made the request, so it's going to create one for you and store it, right? So it's doing something even on a get, right? If there's no token for you, I'm creating one. Right, and then it says, okay, does this endpoint require CSRF protection? Because if it's a get endpoint, it doesn't really matter. I'm not sending data. I'm just visiting the bank website. So I don't need to protect. No one is going to fake my gets to transfer money. So here it says, ooh, does it need protection? No. Well, filter chain, do filter. This is basically what we did in the robot authentication. The robot filter was basically no header, continue, it's fine. Then it says, I'm going to try and grab the actual token from the request. So, okay, we have established that you must be protected here. So it means you must pass us a CSRF token. So either in a header or in a param, we take it out, and then we say, is it the same? Is it the same as what we know from your session? If it's not the same, then we're going to send, we're going to throw an exception. So we're going to say maybe maybe missing token or maybe invalid token, depending on what you're doing. And the handler here, basically it says, ooh, I'm going to say a 403 or show an error page, depending on what error happens. And then if they were equal, then that means the request is legit, and we pass to the next filters down the chain, and we execute the request. So what this shows us is that first, every filter is kind of the same, right? It has the same, do I care about this request? Yes, I process it. Okay, it's processed. Was there a problem? Was there something bad? If that's the case, I throw an exception, or I write to the response. And then if everything's fine, pass on to the next. The second thing that I think is interesting this shows is that to effectively extend Spring Security, in a lot of the cases, you need to understand the protocol or you need to understand the protection. You need to understand the attack that we're protecting against to change the behavior. Because otherwise, it's bizarre to read this, right? What is this token repository? What is this token anyway? And then why do we do equals constant time? And then what's the access denied handler, right? Maybe I want special error pages for CSRF attacks, or maybe I want to do a special log, right? This is a typical case, right? I want an SMS sent to me when someone sends a CSRF token that's invalid. Then I need to override this access denied handler that will look at the exception, send me an SMS, and then proceed with the request, or maybe put something in a queue or something. So if I don't understand how CSRF protection works, it's going to be hard to extend. Same for OpenID, right? Google login, if I don't know how OpenID or auth2 works, it's kind of hard to like understand where in the chain of things that happen I need to put my code. Other filters. So you remember we put a breakpoint in the default security filter chain constructor. So we saw the list of filters that were involved in processing a request. You can also put, if you want to debug, you can also look at the filter chain proxy, and the filter chain proxy in the do filter internal. You remember there's this filter chain call, so you can put your breakpoint here. If you want a higher level thing, if you have a running app in production and you want to see what's happening and where it's failing and why it's failing, Spring Security has great trace level logs. So let's do this in the application, right? If we do logging.level and we say everything in the package org.springframework.security is going to be at a trace level, and we start again, it's going to be very verbose. So the startup is the same. You can notice here it gives you a little bit the shape of your filter chain. Here we can see some filters already. But what's interesting is that when we make a request and we say, let's say we make a request with X-robot password and we put the wrong password, beep beep, right? It throws and says, no, I'm not going to secure this. Then I'm going to, unfortunately, have to zoom out a bit to read this. But it says, I'm going to, there's a request that comes in, and it's on the private path or endpoint. And, ooh, let's remove the wrap. That's what we need to do. Okay, cool. And then I'm going to invoke the filters one by one in the chain. So disable URL encoding filter is the first of 18 filters. Then this one, web async, blah, blah, blah. Security context persistent filter does some stuff. Okay, CSRF filter did not protect against CSRF because it was a get request, so I don't need to protect, so on. And then we get into invoking robot filter. And nothing happens after this. So I have a good clue that this should have gone to filter number 10, but it hasn't. So it's probably because something blew up in the robot filter. Same if I try, and log in with the username password, I put a wrong password, I'll see that I will fail in the username password authentication filter, and it will give me info about how it fails. So for demo purposes, I'm removing this because it's just too verbose and we can't really see what's happening. Okay, any questions about filters in general before we move on to the next section? Yes?
Can you speak about ways how to use CSRF without a session?
Can you speak about ways to use CSRF without a session? No, I can't. I would have to think about this. Yes. So if you're doing stateless, so now with the same site cookie protection, you're usually safe with CSRF. If you really want to do CSRF without a session, you could. There's an authentication mechanism. You're using an authentication mechanism. So maybe you're using a JWT token, a JWT, and maybe you send that JWT token. So maybe what you could do is your CSRF token repository is a mapping between a JWT token and a CSRF token, right? And you could say, ooh, well, there's an authentication that comes in and it matches this special JWT token. But then that means you would use this CSRF filter here, and then you would have to seriously overload this request, right? So I have to extract the token, make sure it's here, and then does it match something in my Redis or something? But it's possible. I think it's interesting to read about the CSRF attack and see if it's when you do threat modeling, is it a threat for you? If you have the correct same site properties, it should be fine. Cool. All right. So we did filters. Now authentication providers. I really couldn't think of a subtitle to this. So remember the authentications I mentioned in the beginning. I lied in public. Or I oversimplified a little bit about the authentication objects. So I said, they represent a logged in user, and is authenticated is always true, and the credentials are always null. If that were true, then having this is authenticated method would make no sense, and having a credentials getter would make no sense either. That's because they actually filled two purposes. They represent actually either a logged in entity or a bundle of data, a bundle of credentials that need to be authenticated to validate that this is a legit entity that wants to log in. So they represent either the request to log in or the result of a successful login request. And this processing of transforming the username and the password into a username password authentication token with the correct properties is done in an authentication manager. So authentication manager is a very simple interface. Authentication manager, this one here, right? It only has one method, authenticate, and it takes an authentication object in and returns an authentication object. Usually it's the same. So in that example here, we have an authentication password authentication token, username password authentication token that goes into the authentication manager. And then the authentication manager, if the password is correct, if the user is not, if the account is not logged, if it's not expired, it returns a username password authentication token. The objects are the same type, the contents are different. So the username password authentication token has username and password, but the result has the user details, so a richer object. Maybe it has my birth date, it has my favorite color, it has a kitty emoji because I like cats, and it has the authorities. I'm an admin, I'm a user, I'm allowed to read the messages, I'm not allowed to write to the admin console, right? The authentication manager can either return an authentication or throw an exception, an authentication exception, right? And that's it. So this class is very easy to implement because there's only one real implementation, which is the provider manager. The other are wrappers and the no-op, which is an internal thing for a special filter. But basically, everything is a provider manager in Spring Security. A provider manager, I think I have a slide for this. It's just like it's the kind of the same idea of the filters, but applied to transforming authentication requests into authenticated objects. So it's a for loop over a list of authentication provider. An authentication provider here, authentication provider. This one has two methods. It has authenticate and it has support. So basically, this is the specialized version of the provider manager that says, I only deal with username password authentication tokens. I only deal with robot authentications. I only deal with OAuth2 login authentication tokens. And this allows you to extend Spring Security in a very specific place for changing the way someone logs in without having to write a custom filter that takes the request, that does some transformation. Maybe you don't need to go that far. Maybe you have special rules around the email of the user that comes in. Well, here an authentication provider would be good enough, and we'll see how we use that. One thing that's important to know is that usually your app has a provider manager. So a filter chain has a provider manager inside. A provider manager may have a parent authentication manager. So if you have multiple filter chains, they can have common authentication mechanisms and then separate specialized things. And then sometimes it's a bit hard to debug, especially with the security config. Here, this user detail service is actually swallowed by some configuration somewhere in Spring Security. That happens when you do enable web security. This one here has a web security configuration, and it has a thing, not web security, the HTTP security configuration. It has a thing that creates some authentication manager based on stuff. So sometimes you don't see all the authentication providers. That's because Spring Security created a provider manager for you. So when you look at a provider manager, you may have to look at its parent. But scrap that for this. We're just going to do one provider manager and see with this. So authentication provider, we talked about this. And so let's see this in practice. Our website is great, right? It has 2 beautiful pages. I can log in with username and password with Google Login. I have a robot account that can hit my endpoints and get stuff with credentials that are not in the database, for example. The problem with my website is that I have an admin called Daniel. He's really fine. He's neat, he's kind, he's very handsome, but he has really bad memory. And for the love of anything, he cannot remember his password. That's very unfortunate. So we're going to make an escape hatch for Daniel so that he doesn't have to remember his password. And so we're going to do this by implementing a special authentication provider. So let's do this. Daniel authentication provider. Cool. So this implements authentication provider, right? Implement the method, and we have to implement 2 methods. So one supports. So which type of authentication objects are we going to look at with this authentication provider? Well, only username, password, authentication token types. So if a robot comes in, I know it's not Daniel, so I don't have to check the password or anything. So I am only going to deal with username, password, authentication token. And so in here, when the provider manager calls this authenticate method, it's going to always pass in a username, password, authentication token or a subclass. And so what do we do with this? Well, we say authentication.getName, right? This is the name, username, and we say if Daniel equals the username, then we're gonna let go. Otherwise, we're going to do something special. So if it's Daniel, well, it's successful. Like we just need to know the name. So we return a new username password authentication token. Username password authentication token, authenticated, right? And the principle is going to be, well, the name is Daniel. It doesn't need credentials because I don't need password, and I'm already logged in. And then authorities, let's say that we have admin, right? Daniel is admin. So what do we do in case it's not Daniel? Well, we don't know what to do with this. Like the user password, this must be handled by some other authentication provider. So to signal this, we return null. Right? So this is saying this is the same way as we did with the filter, right? Do I want to handle this request? Is it the right type? And is the content of the payload the thing I care about? So we could flip it around and return null or whatever. The other thing that the authentication provider can do is throw an authentication exception. So basically, this account has expired, and so you're not allowed to log in, or the credentials are wrong, or I don't know, the planets are not aligned, so you're not allowed to log in today. You are only allowed to park on this side of the street on even days of the month, and so today you're not allowed to be there. So 3 things, right? Authentication provider returns either an authenticated thing, so the result of something that passed me credentials and I said the credentials are good. An exception if I want to say stop processing, this is invalid, this should not go further, or null if we delegate to the rest. If nothing can authenticate, if every provider returns null, it will throw an exception in the end. The provider manager will say, no, I don't care about this. And so how do we mount it into the filter chain? Well, again, we go to the security config and we say, hey, authentication provider, a new Daniel authentication provider, like this. And will be added to the provider manager of the chain, and it will, when a username password authentication token is made from the request, and something tries to authenticate it, if the name is Daniel, we should let it through, right? So run this. In here, private, right? So if I do user blah, this fails, bad credentials, user password works, all right? And then if I go to login again, and I use Daniel, and I don't look at this, then I'm logged in. I don't need the password. So this is typically what you should be doing in production, right? No password for your admin. Cool. All right. So that's the thing, blah, blah. One interesting thing about this. So what's interesting with the provider manager is that it has some logic in it and it does some stuff for you. So the provider manager, for example, produces logs. So there is a wiring that I need to do here. Authentication event publisher. So and then we see HTTP get shared object authentication manager builder, right? And then set shared not set shared object. And then event publisher, and then can I wrap this in a thing like this? Can I put it here? Does that work? Right? And then voila. Don't look. So this will disappear in Spring Security 5.8. We have the patch for this, but it's not here. If you use the web security configure adapter, you don't need to do this, but it's fine. Just ignore, it doesn't exist. So the provider manager, when I log in, it produces an event. When I fail to log in, it produces an event, a Spring event. So that means we can listen to those events and do stuff when an event is done. So we create an application listener bean and we're going to look for authentication success events. So success listener, right? And so basically, when an event comes in, we're going to do stuff. So for example, we're going to log to the console, and ta-da, right? Success. And then we're going to put the type of the authentication, and then we're going to put the name. Can I format? Right. So success, and then here we're going to say the event has an authentication and it has a class, and it has a name. So we're going to get the type of the authentication, and then authentication, get authentication, and maybe we put the name of the authentication. All right. So this is just logging as success. So if we run this, cool, and we log in here, come back to private, user password, right? Then here, I obtained a username password authentication token. Maybe we'll put a simple name to get simpler thing, cool. And then if I log in with Google, right, then I get a auth to login authentication token. So I can log stuff, right? I can log successful authentication. I can log failed authentications. And this is all offered to me by the provider manager, by the whole idea. And it processes exceptions and it delegates to other So usually, when you want to do custom authentications, you do a custom authentication provider rather than a full filter. So if we want to change our robot filter to use an authentication manager, we can do that. So we have an authentication manager. We need an authentication manager, right? And then this needs to be passed into the constructor. And so in here, it will use the robot filter. We use that authentication manager to transform an authentication request into an authenticated object. So in that case, an authentication request should be a special type of robot authentication. We're going to change this one. So is authenticated, we're going to make a field out of this, is authenticated, right? And then the authorities, we're going to make a field, authorities, right? Because these will depend on whether this is an authentication request or an authentication object. So perfect. And then we're going to need a password, right? We're going to pass a password and we're going to check that password. And so let's do a public string get password, right? And this will return a password. No, I don't want to insert this. I want to create a field. Beautiful. And make it final as well. Okay. So then we can make a constructor. Yes. And then in the we're going to pass the authorities as well. Cool. Add to the constructor. Authorities. Yes. Fine. Cool. And this is very like, when are you logged in? Well, is authenticated is when the password is null. So when I don't pass a password, I'm authenticated. And this is too hard for my users to understand. So usually, and this is what is done in Spring Security, you create static methods for this. Public robot authentication, unauthenticated, authenticated. One takes a password, right? And this calls return a new robot authentication of, let's say, collections.empty and the password, right? And then we create another method for robot authentication, authenticated. And it takes nothing because I don't need to know any details about the robot. And it's a new robot authentication, and the collections are this, the authorities are this, and there's no password, right? Okay, so we have our transforming, or our two states, right? Authentication request, the credentials, and I'll show it again. Authentication request, the credentials, so basically your password, or authenticated, which is just authorities. And so in here, we're going to do something slightly different. We're going to say we're going to extract the password, and so from that password we can make an unauthenticated. Are these public? Yes. Oh, they're not static. Thank you. Static. Static. All right. We're going to make an unauthenticated version of this, and then we're going to see this is an auth request. And then we're going to call authentication manager.authentication of the auth request, right? And then this is the authentication, successful authentication if it works. And then if it works, then we can put it in here, this thing, boop, right? And then this, we want it to fail if the password is wrong. So this is going to wrap this in a try catch. Maybe wrap the whole thing in a try catch. Try, right? And just authentication exceptions, right? So if we're authenticated, we just do the filter chain thing, cool. And if we're not authenticated, we get an authentication exception, and we're going to handle it. And then you're not Mrs. Robot. We're just going to get the message instead here, the message of the error. So now the only piece we're missing, right, here we go, e.getMessage. So the only piece we're missing is what transforms an unauthenticated robot authentication into an authenticated robot authentication. If you've been following, it's an authentication provider. 2 people. Nice, 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 nice. So we create a robot authentication provider, and this implements authentication provider, right? We implement the method. So supports, it's only robot authentication classes, right? This should not try and fiddle with username password authentication token or stuff like that. And in here we say, well, authentication, we know it's a robot authentication. Call it auth request. And then what do? We do auth request get password. And maybe we do something funkier. We do a private final list string passwords, right? We do a list of available passwords for our robots. Port list, fine. Create the constructor, beautiful. And then we say if the password, but this should be passwords. Passwords, there we go. Yes, fine. If passwords contain the password, then we're happy. We'll return an robot authentication dot authenticated, successful. Else, throw new authentication exception. And so authentication exception is an abstract class. So we want a subclass of this. And here, bad credentials looks good, I think. Bad credentials exception. And then here, you're not Mrs. Robot. Ooh, very nice. There we go. All right. And so maybe again, invert the if, and then in that case, we'll remove the else. Right. And so now we have a robot authentication provider that has a list of passwords. If the password we pass in matches one of these, then we're authenticated. If not, we have bad credentials. So now what's missing is wiring all these things together. And we do this again in the security config. This is the place where we wire things in. So here we need to pass an authentication manager in here. For now, I'm just going to create one out of scratch, and then we'll see how we make this slightly cleaner later. So we said authentication manager is always a provider manager, and then this is going to pass a robot authentication provider, and it has a list of passwords, beep, boop. And then we're going to accept boop, beep. Wow. And this should be a list. Can this wrap? Copy, no. So list of this, right. Import me list, please. Cool. So we have a provider manager and then call it auth manager. This is the typical name. And then I'm going to wire the event publisher in it because. Cool. And then so our robot filter now takes an auth manager. Right. So we did a lot of things. We split the logic a little bit. The logic for transforming a password into a robot authentication now goes into the robot authentication password, robot authentication provider. Check the password. If it works, then the robot filter is happy and takes the successful authentication, puts it in the context. Otherwise, it catches the exception and then returns. So if I have not messed anything up, cool. We should still be able to have beep beep. Beep boop should work. There we go. So beep boop works. Boop beep works. Nice. But boop boop, you're not Mrs. Robot. And what's cool with using the provider manager construct rather than doing stuff in the filter itself, and then being very like, oh, I take the request and I do stuff with the request, I do authentication, is we separate the concerns and we get free logging instead. So now we have login. You produced a robot authentication for Mrs. Robot, right? And so you get all the benefits of the provider manager, of logging, of authentication success, of retrying with a parent provider, et cetera, et cetera. Cool. All right. That's a lot to take in. Do we have questions around this? Authentication providers and authentication managers. Go ahead.
Yeah, in the authentication provider, in the supports method, there you can this parameter any class. Is there a reason why this class isn't specified more with generics?
So the question is in robot provider. In support, why is authentication not specified with generics? It's just any class. I don't know. It's probably legacy reasons. This is very, 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 very old. Like Ben Alex has been gone for, I wasn't at VMware at that time. So I think it's one of these core things that hasn't evolved in its API. Right, see the copyright is from 2006. And so that's probably the legacy reason, and it's so core to the architecture that it probably doesn't evolve. And maybe there are very good reasons that I'm not aware of as well. Cool. All right. So authentication provider, very similar to the very similar to the filter chain, right? It's a list of things that we try out. Also, if we do tracing again, this one, we reintroduce tracing, run the app again, and we do login with login, and we log in with the user. We also see user password. In here, we also see that we're securing we're posting to login, right? And then this goes into the username password authentication filter, and then it tries to authenticate with Daniel authentication provider. This one returned null, so it's trying with the rest, and then it's trying with a DAO authentication provider, and then it authenticated the user called user. So we can trace a little bit more, right? Oh, it tried with this failed, and so I'm trying this one instead, and so on and so forth. What's really nice as well with these authentication providers is security config. It doesn't care about the shape of the request, right? It doesn't care that the password came from X robot password. It doesn't care that I tried to log in with a post request. So for example, if we change our app and we say, we also support HTTP basic, by the way, right? So instead of making a browser calls with a post, I'm going to make curl requests and pass the login and the password in it. So this says user password. This, we haven't changed anything, or this is not specific to our app or to our provider. AT&T private, right? This works. But now I want to extend and also support Daniel anything, right? And it works because it doesn't care, the authentication provider doesn't care about the request. It only cares that there was a username password authentication bag of credentials that was produced by something, and then it authenticates it. So for free without having to fiddle with filters. And usually going more specific is more interesting than doing filters, because if I wanted to do the special Daniel filter, I would have to check the post request, and then I would have to check the authorization header, right? With HTTP basic, we have a special authorization header, so I would have to base 64 decode it, split the colon, so on and so forth. Cool. Make sense? Yes. So the question is there a way to, so since the authentication provider can return null and delegate to other authentication providers, is there a way to order them? Usually there will be only one provider manager. It will be in the chain, and it depends where where in the filter chain things are declared. So if you declare several of those, the topmost one will be at the top of the list, basically. So it's an ordered list. So usually authentication providers, you put them here, like before other stuff. But we'll see with the configurers how this is done. So in here, in our filter chain, it's going to prioritize form login over HTTP basic over auth to login. So if I send a weird post request with the username and password in it, and also the basic authorization header, it's going to perform form login in priority. If I swap this, if I send my post request from the browser, but I also add the credentials in the HTTP basic header, it's going to use HTTP basic instead. Right? So if I use Daniel in HTTP basic and user in the form login, in that case, it will prioritize Daniel. And then in that case, it will prioritize the other one. So the order is how things are declared in the filter chain. Okay, so now maybe the recap of this, right? So authentication, it's a bag of data that needs to be authenticated, and it's the successful result of this. The transformation between a blob of credentials and actual user data or entity, logged in entity data happens in an authentication provider. And then that's where you should create your own rules for authenticating. So maybe you have some special cases around usernames or something, then you can create your own username authentication password. And of course, it depends what you want to do, but it's usually a very good place to put your own logic rather than creating an entire filter, which is very involved. So then we get to the very interesting topic of configurers. Configurers are an abstraction that allows you to configure the filter chain and do multiple operations on the HTTP builder here with one call. And so basically what's happening here is that this is calling a special form login configurer. We'll get into that later. We're going to change our own setup to use a configurer instead, and then we'll explore the existing configurers. So it would be really nice that instead of doing this and having to create a provider manager and also having to add both a filter and also a authentication provider, if I extract it for, right, we have this like 1, 2, 3 objects for our robot account. It'd be nice to be able to do something like robot login, right? So you will not be able to do robot login by yourself unless you extend the HTTP security class, but it's final, so you can't. So you would need to be able to contribute to Spring Security to do this, to create your own robot login. And I think they will say no. I haven't tried, but they probably will say no. However, you can apply your configurer with a slightly more involved syntax. And you say, I'm going to apply a robot login configurer here. And then I have to call and we'll get into this. So this configurer, created, cool. This must extend, do I get this right? Abstract, extends, abstract, HTTP security, HTTP configure of a robot login configurer and an HTTP security. So, oh, not builder, HTTP security, right? So this is a special class that has 2 interesting methods, init and configure. So this is step 1 in the configuration process, and this is step 2. So this initializes a bunch of objects, and this also initializes objects, but can reuse objects from step 1, even from other configurers. So basically, there's a loop here that happens in, can I remember the class? Abstract, in security configure adapter, do configure, or I am not sure, or in the builder. I can't remember. this one is a secure. No, I can't remember exactly where it is. But there's a loop that says, like, take all the configurers that are in this filter chain, run init, and then do a special step, and then take all the configurers again and call configure. And so basically how this is actually used, here you put the authentication providers, and then here you put the filters. This is like this. So this is what we're going to do. So our builder here, just for consistency with the rest, we call it HTTP. And so here, this is exactly like when creating a filter chain. We can call any of those methods. So in our case, we want robot login configure. We want to add an authentication provider, which is a new robot authentication provider. I mean some passwords here. I'm going to create a list of passwords. Create constructor. Doesn't a robot authentication provider take yeah, it takes a list of passwords. Passwords, IntelliJ, you are too slow. Faster, 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 faster. There we go. List of passwords, make a final list of passwords in string, and it's a new array list, fine. And so what are we going to do with this? We're going to have a public method here that returns a robot login configurer, and that's called password to add passwords. So kind of a builder pattern to add passwords. This.passwords dot add the password, right? So it's now the configuration of the passwords can be done outside of the configurer. Fine. Sorry? Yes, return this here. Correct. So otherwise we can't do builder, thank you. And then in here, we add the filters. So we can add a filter before, and then this is going to be a new robot filter, right? And then we are going to add it before, yeah, I don't know, username, password, authentication filter class, why not? Or maybe security filter interceptor. Hello? Filter interceptor. No, filter security interceptor. I got my thing in the wrong order. Okay, cool. And here we need an authentication manager. Now the filter chain has one in here, and so we can get a shared object of class authentication manager, not builder, just manager class. Import it, authentication manager. So this get shared object is Spring Security re-implementation of application context in Spring. So it's kind of beans. You have this like repository of objects and you put things in them. Here, all the authentication providers are populated at init. They're put in the builder, and then we call build, and then an authentication manager is made to be reused in later steps. This is because each filter chain may have their own authentication manager. So you can't just have beans, because that would be global. Okay, cool. So now this is implemented. It's very simple. We can use it in the security config. And so instead of having all this, right, the robot login configurer, I'm going to extract it. We don't need an auth provider anymore, right? Because this is done in the configurer. And so now we could say the configurer has a password, beep, boop, and a password, boop, beep, beep, right? And this is exactly the same as what we had before. So if I run this and I haven't broken anything, which is not guaranteed, we could do beep, boop, and it works. Oh, boop, beep, I guess. And if we do boop, boop, this still doesn't work, right? Why is this interesting, and what pattern do we recognize with this? In here, if I decided to apply the new robot login configurer here, when we look at the return type of these things, this returns me a robot login configurer. Apply here takes a configurer of type C and returns a configurer of type C. And the configurer which is the security configure adapter thing, has somewhere in its hierarchy an AND method that returns a builder, that returns HTTP security, basically. So here, we go back to HTTP security. So with this, I can do a DSL. I can do password beep boop and password boop beep. Boop beep. And this is exactly what you see when you do go away project view. Cool. When you do form login here, and you do username parameter is utilisateur, oui. And le password parameter, c'est mon mot de passe, right? And the next, right? So you can do the same thing. You can do the same kind of DSL, even though now that's not the recommended way of doing it. So let's look at the ways, the recommended way of doing it is boop, boop. So this is what we've done, right? We apply it. So form login configure, I can apply it in 3 ways. I can do http.formlogin and then the Fluent DSL that you were used to in the past before 5.7 or 5.6. You could create a form login configurer like this and then call login page and so on and so forth and then apply it and call AND. Or you can call form login and then pass a lambda that takes a configurer and changes it. So basically doing all the thing after it's been created. So it's just it applies this consumer of form login configurer. Why is this interesting, this lambda DSL? This is because this matches what we have in Kotlin. So does anyone do Kotlin Spring here? 1, 2, 3, 4, 5, 6. Yeah, it's pretty cool. I like it. I like Kotlin Spring. Even though now with Java 17 we're getting closer to Kotlin, but you can do this kind of DSL and it reuses the same mechanism of the lambda. So this is the Kotlin equivalent is this lambda here. And you've seen me call with defaults a bunch of times here. With defaults is a cheat. It's a function that does nothing. So it's just to call the correct method. So with defaults is it's exactly the same as doing a lambda that takes a configurer and does nothing with it. And it's the same as calling formlogin.and, http-basic.and, csrf.and, one after the other. Cool? Okay, do you have questions about the configurers? Yes. No, so we cannot support the lambda style, but if you want to do something that pretends it's a lambda, you remove this parenthesis here and you put it here. And so it's not a lambda, but your object with the builder style is already inside the thing. But, so, cool. So, now that you know this, that the HTTP security filter, the security filter chain is configured through configurers, and those configurers are applied with these special methods, because when we look at it, this is a auth to login configurer, then you can go and navigate Spring Security yourself. And you can go and understand a little bit what's happening. So for example, here's the auth to login configurer. And it tells you things. It tells you this is for auth to login using the auth to authorization grant flow, and it needs an account with either an auth to provider or an OIDC provider, and it's going to create this filter here and this filter there. It's going to create these other objects, and it's going to reuse the client registration repository. So if it's not present, it's going to complain. This one is optional, so it may create one for me, so I can see a little bit the classes that are used. If I want to learn about the details and not the lies of the documentation, I go into the init method, and in it you will see a lot of authentication providers. So if I try and highlight those, right? So I create authentication providers and I customize them and then I put them in a filter chain. And then you can see, oh, there are 2 authentication providers here, either an auth2 login authentication provider or an OIDC authorization code authentication provider. And here are the things I can customize. And so learn a little bit how they go and what they do. And then if you know the auth2 protocol, then you can go into the authentication provider and decide some stuff. So for example, oh, this authentication provider, it checks whether there's an OpenID scope. If that's the case, it returns null because it delegates to this other provider. And so you can go and start unpacking the different authentication providers, so how to transform authentications. And then in the configure method, you can see the filters that are added, right? So if I look at filter here, I can see the different filters that are created. And I can then open them and look inside. And there's necessarily not that much in a filter usually. Even though sometimes you need to know if you want to understand the auth2 login authentication filter, it will be much better to understand the auth2 protocol because we do a bunch of things inside because the protocol is complicated. But usually it's followable, and this is how I learned. Just reading the docs is usually not enough if you want to customize some tweaks and very specific things. Okay? Questions? Okay, so there's one last thing that I want to show for sure. We have time, beautiful. Security config. Now, we have a new use case on auth. And we want to extend the existing behavior for auth2 login. And I want to allow only 1 login per Google user per minute. So if you try and re-log in multiple times, I want the application to tell you, oh, you're going too fast. Now, this would be a bit complicated to do, like with a filter, it doesn't really make sense. So we have to plug into this auth2 login mechanics. And there are multiple ways of doing it. But if you remember, when we are in the web controller, that's not the web controller. Hello. We're in the web controller. Ooh, we already have a breakpoint. Amazing. You go away. Beautiful. And then we go to private here. And then we log in with Google. Oop, we get here. And so when we're logged in, we have an auth2 authentication token. So the type of authentication is an auth2 authentication token. So I can navigate to that class, auth2 authentication token, right, this one. And then I can say, who uses that? Which classes use this? And a bunch of classes use this. But what about the classes that say provider in them? Wait, I got the name wrong, I think. My bad. I would go with the default OIDC user. My bad. Default OIDC user. So, oh, and these are the user service. Let's start with a token instead. All right, so who uses the default authentication token? So I would expect a provider, but there are no providers here. So instead, I'm going to try my luck with something that I know, a filter, right? And the filter here does some stuff with the auth2 authentication token, attempt authentication. And what does it do? How does it convert? Well, it takes a thing that's an authentication result, and that's an auth2 login authentication token, so another type of token. So let's take at this, and do we have providers here? Yes, we have providers. And so we have authentication providers that take an auth2 login authentication token and take that bag of credential and make an authenticated thing out of this. And so we have auth2 or OpenID. So in our case, it's going to be OpenID. And so I would like to change this OpenID behavior and add some rate limiting. Now, to do this, I could create my own class. And so in here, rate limited authentication provider. Now, there are several problems with this. So if I want to extend OIDC blah, blah, blah authentication provider, then I need a constructor. And then in here, I need some very complicated objects, or some complicated generic objects, right? The auth to access token response client. And maybe I don't really know what this is, and maybe I don't want to delve into this. Like, what's the default? How do I make one if I want to make one myself? So instead, what we do is we're going to ask Spring Security to wire this for us, and then we'll just add or sprinkle our behavior on top. One other problem you might have when you want to extend Spring Security is that some classes are final. So you cannot extend them. And all the classes we add in Spring Security currently are final, so you cannot extend those. So usually, the pattern you use here is composition instead of inheritance. So here, this is an authentication provider, so it implements authentication provider, right? These two methods, and it's going to wrap around something that's provided by Spring Security. And it's going to wrap around an other authentication provider, in our case, an OIDC, authorization code, something, something provider. And we call this delegate. This must be passed in some way. And so support, it's going to support the same thing as the delegate, right? So here, in our case, the OIDC, blah, 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 supports OAuth 2 login authentication token, so we're going to support those as well. And basically, we're going to ask the delegate to do the authentication for us. And this is the parent authentication. So it does the authentication, and then we decide, you know, like, is this, have we hit the rate limit yet, or have we not? And so maybe we can say, oh, if I can update the cache with the parent auth, then that means I'm fine, right? And otherwise, I return, maybe I throw new back credentials, whatever. Cowboy, not so fast, right? And so there, we have to do this logic for caching. Returns a Boolean, parent auth, beautiful. So maybe this is implemented with a very secure and scalable concurrent hash map of string to instance, right? Cache instance no s, cool. And a new concurrent hash map, cool. Implement instant. This can be a map, that's enough. And so what do? We do map the cache.get parent auth. We'll do them by name, right? This is the previous instant. And now is now, right? So, and then we update the cache. So we put parent auth get name and now, and we can return. So if the previous instant is null, that means there was no entry in the cache, so this is fine. And then otherwise we can check the previous instant, the previous login, maybe we call this previous auth time, right? And so if the previous auth time plus 1 minute of minute 1 is before now, right? So if more than 1 minute has happened since the last login, then we return true. The update was successful, or it's fine. So if we can log in, cool. If we have logged in too soon, we throw a new bad credentials exception. Okay, so now we need to wire this in, and so we need to pass a delegate, an authentication provider delegate, and that means in the security config again. So in here, we could add an authentication provider. Authentication provider, a new rate limited thing of a new OIDC. But if we do new OIDC, we have the same problem. I don't know what to put for the auth to access token response client. So to do this, I could go into the login config, the auth to login configure, and then look at these. What are the default for the access token a token response client, right? Like, what's the default? It's this. So I could do that. But instead, what I choose to do is changed a little bit the OAuth to login configurer. Because if I go into here and I look at the OIDC authorization code something provider, my authentication provider here, it creates it, it changes some stuff, and then it adds it to the filter chain after calling post-process on it. And post-process is a thing that allows you to transform object that Spring Security has wired for you. And so what we can do instead here is the auth to configure, we're going to extend it, and we say auth to configure with an object post-processor of authentication providers. So we're going to update the authentication providers. And so in here, we're going to return a new rate-limited authentication provider of object. And we need to cast this to O, right? And so basically here, what we're saying is that we're telling Spring Security, do your wiring, do your stuff. Once you're done and you have a nice object, I just want to take it and add a little bit more on top of it. And so I'm taking it and I'm wrapping it in my own behavior, in my own rate limit. And so if I'm not too tired and the demo gods are with me, we'll see. So now I should be able to log in. Boop. The demo gods are not with me. This is probably because this thing can be null, right? This can return null if parent auth is null, return null. If it doesn't know what to do with this, so try again. Boop, boop, boop. Localhost 8080, and then private, and then demo gods, are you with me? Okay, I can log in, but now if I try to log in again, it should go into my provider and tell me not so fast, right? So I have extended what Spring Security gives me without having to worry too much about the defaults and how it applies different things by just wrapping a thin layer of very perfect caching on top of an authentication provider. And so this, as you may have noticed, I take any authentication provider, so we can make anything rate limited if we wanted in the security config. Our Daniel authentication provider could wrap around this, and then we could do the same for the form login, for HTTP basic, for everything we want. We can just extend and transform the types of objects we have. So practical use case we have with this. I work in Tanzu Spring, I work on the app SSO team. So VMware has this layer on top of Kubernetes, the Tanzu application platform, and our team is providing SSO capabilities to enterprises. And our authorization server, they give you tokens, but then the authorization server itself can authenticate you with OpenID providers, with LDAP, with SAML, with username and password. And so we have different types of authentications that come from upstream providers, and we save them to we save the tokens to a database. So what we do is we extend each of these authentication providers, the SAML authentication provider, the OpenID, the OIDC authorization code authentication provider, and we take the object that was produced and we transform it in an app SSO authentication. So to the consumer part of our application, everything is an app SSO authentication, right? So, and just by changing the little bits, extracting, we know where to extract the roles of the user, we know where to extract the email, and so on and so forth. So that's one use case. Do you have questions? Apart from, can we go now, please? Yes?
It appears to me there are like several different ways to achieve the same result when configuring things. So this is, of course, very flexible, but it's also very confusing. So are there maybe plans in Spring Security, like, for example, with a major release, like to consolidate these options?
So the question is an observation first, that there are many ways of achieving the same result. So this might be confusing. This is why you're all here, I guess. And the question is, are there plans to simplify this a little bit? Yes, but it's probably not going to be simple as you want. because we have hundreds of thousands of users, and out of these hundreds of thousands, 3 use this one little entry point thing here, and 4 use the handler, and so we can't. This would be too much breakage, and it's not the philosophy of Spring Security, and so I think it's not planned for 6.0, and I'm not seeing plans of reworking the entire model for 7.0. So it's going to be complicated for a while. Before more questions, one last thing that is interesting that you should know exists. Remember when we did the first example and we had the form login, right? Like I just included Spring Security and then had a form login. And I could log in with a username and a randomly generated password. Where does that come from? That comes from Spring Boot. So Spring Boot has auto-configuration mechanisms, and it's interesting to know where they are to understand what they do and how they do it. Because they do sensible defaults on a bunch of things. So for example, here, if you know the auth protocol, that's not enough to perform a full auth flow. You're missing information here. Actually, if this was called foo instead of Google, my app would not start, right? Because Google is a very special name. We know stuff about the Google login that will never change, and this is encoded in Spring Security and called by Spring Boot. Where is this? So there are 2 ways to find this. So either you go through the security config here, and you're like, okay, I have a auth2 login that has an auth2 login configurer, and it has a bunch of objects in it. And I want to be looking at the objects that are not filters and not providers. So repositories, that's a good start. So I can navigate to that and look for usages. And I would have to look into something that has configuration in it and that is in Spring Boot. So if I look for configuration, right, I have these, okay, auth2 client configuration, that looks promising. Okay, not that much. So try the other one. Usage, configuration. Auth2 client repository configuration. Oh, we're in Spring Boot, it's configured. That's a good sign. And what do they do? Well, if the user has not provided a client registration repository, then Spring Boot is going to create an in-memory one for you. And how does it do this? Well, it's going to read the auth2 client properties that you can go and see. And you can see that, oh, that's the Spring Security auth2 client, if that rings a bell. Application YAML, right? Spring Security auth2 client. So this comes from Spring Boot. It reads those properties in the auto configuration, and then it does something with it. So it does a bunch of logic, and I can go and drill in here, and I can say, if I take the time, I can say, ooh, get common provider. It's in common auth2 provider, and then boom, a magic Google enum that has a bunch of information we know about Google. So if you use Google, so this is in the Spring Boot docs, you could find it in the docs, but just by reading the code and following how does it transform my properties into something that Spring Security uses, you can find these things. Oh, we know how to support GitHub, which is not OpenID, it's auth2, and so it has a user info URI, which is different. We support Facebook, and so on. So this Spring Security supports or like maintains those URLs, and then Spring Boot does the automated wiring for you. If you want to find the automation through Spring Boot and not Spring Security, so you remember we had in the build.gradle, we added this Spring Boot starter auth2 client. So that's not where things are. This is just a dependency resolution jar that has other dependencies. All the magic happens in Spring Boot auto configure. So you can go into your editor, download the sources for this, and then look inside and look at all the things that Spring Boot can auto configure for you. And since we're doing Spring Security, right, you should be looking for security. And then we have auth2 that looks promising. It's not a resource server, it's client, and we imported OAuth to client. So we go into client, reactive servlet. So we're doing servlet. And so I only have 3 classes to look through. This one is the shortest name, so probably in this one. And so I can check, okay, if I have a client registration class on the class path, then I'm going to, and the server is a servlet server, then I'm going to import these 2 things, and then we go back to that, which was the client registration repository we found through Spring Security. And so here you can understand what opinions Spring Boot has for you. It's in the docs, but if you want to see the code and all the transformation that happens, because this adapter here is still, it's 150 lines of code, so it has a bunch of opinions, then you can go into this one package. Okay, I'm going to stop torturing you with this because this is way too much. So here's the code, the slides, the me on the internet. Come find me after the talk if you want to chat. Come find me during lunch at the VMware Tanzu booth in front of the cloak room. And I don't know what time it is. We have 4 minutes, so if you want questions for the end. Wow, everyone fell asleep. It's so quiet. Well, thank you very much. Have a lovely rest of the conference. Bye-bye.